Hello students, myself Miss Akanksha Gurule. So I welcome you all in our physical chemistry class. So in today's class we are going to study enthalpy of various chemical reactions. So in this lecture we are going to study heat of neutralization, heat of solution, heat of hydration, fusion, vaporization, sublimation and also bond enthalpy or bond energy. So one by one we will learn each and every term. So first we will start from heat of neutralization or enthalpy of neutralization. The heat change that takes place when 1 gram equivalent of the acid is neutralized by 1 gram equivalent of a base. The condition is the reaction being carried out in dilute aqueous solution, and it is similar when base is neutralized by the acid. So first of all we must know what is the neutralization reaction. In neutralization reaction, acid reacts with the base to form the salt and water. So here we will take one example in which sodium hydroxide will react with hydrochloric acid to give NaCl as a salt and water. So whatever the heat change that accompanied when an acid is being get neutralized by the base. So for this reaction, heat evolved is 57.1 kilojoule. That is the heat of neutralization of NaOH by the HCl. So there are 2 points in this. The first is heat of neutralization of strong acid with strong base or vice versa is always equal. That means 57.1 kilojoule. So whichever acid, that means whichever strong acid and strong base reacts with each other to form salt and water, the heat evolved will be always equal to 57.1 kilojoule. So if the acid or the base is weak or both of them are weak, then the heat of neutralization is always less than 57.1 kilojoule. So you must remember that whenever the neutralization is being between the strong acid and strong base, the heat of neutralization will be equal to 57.1 kilojoule, and when one of them will be weak or both of them will be weak, the heat of neutralization will be always less than 57.1 kilojoule. So we will see why the value is constant. For example, we will take the same example when NaOH will react with HCl to give NaCl and H2O. So first we will write this reaction in the ionic form. So when NaOH will be dissolved in water, it will be present in Na plus and OH minus form, and when HCl, it will be present in H plus and Cl minus ion. Is it okay? And when they both will react with each other, the H plus and OH minus ion will form water, that is H2O, and Na plus and Cl minus ion will be as it is. Okay, so now we will cancel the same terms from the both the sides. That means Na plus will cancel out with this Na plus, Cl minus with the Cl minus present in the left hand side. So what is the remaining? That means H plus will react with OH minus to give H2O. So as we have said in the definition that 1 gram equivalent, that means 1 gram equivalent of strong acid and strong base will produce same number of H plus ion and OH minus ion. So whatever the H plus ion and OH minus ion that will react with each other will be same for 1 gram equivalent of the strong acid and strong base, and therefore the value is same, that is 57.1 kilojoule. So the number of H plus ion and OH minus ion given by 1 gram equivalent of strong acid and strong base is equal, and therefore the value is same, that is 57.1 kilojoule. So now whenever there will be the question why the heat of neutralization is equal to 57.1 kilojoule for the strong acid and strong base, now you are able to give that answer, that is the number of H plus ion and OH minus ion given by 1 gram equivalent of strong acid and strong base is same. That is why the heat of neutralization for them is constant, and that is equal to 57.1 kilojoule. So the next is heat of solution or enthalpy of solution. Enthalpy change associated with the dissolution of a solute in a solvent at constant pressure resulting in infinite dilution. Heat change accompanied when a solute dissolves in a solvent is called as a heat of solution. There are two types of heat of solution. The first is integral heat of solution. So what is the integral heat of solution? Heat absorbed or evolved when a definite quantity of solute is dissolved in a definite quantity of a solvent at a constant temperature and pressure. So in integral heat of solution, there is a definite quantity of solute and definite quantity of solvent, and the heat associated with it is called as integral heat of solution. The next is differential heat of solution. It is the partial derivative of the heat of solution with respect to the molal concentration of one component of the solution when the concentration of the other component, pressure and temperature, are held constant. So, what you have to remember, the change in heat of solution with respect to the molal concentration of one component, that may be solute or that may be solvent. So now the differential heat of solution of a solute for a given solution, that is delta H1, is given by. So now you know the partial derivative. Partial derivative is denoted by dabba, that is this sign. So change in the heat of solution with respect to the change in concentration of one component, that is dabba n. It is observed from the above equation that the partial molal enthalpy of solute in the solution is less than the molar enthalpy of solute. So here we will see delta H1, that means for component 1. So dabba of heat of solution with respect to dabba N1, where N2 is kept constant, that means other component concentration is kept constant, where N1 and N2 are the number of moles of solute and solvent respectively. That means the differential heat of solution is nothing but the change in the heat of solution with the change in concentration of one component. That means either the solute, either the solvent, and the other component concentration is kept constant. If here we will calculate delta H2, that means change in the heat of solution with respect to the change in the concentration of N2, where the N1 is kept constant, that will be for delta H2. Is it clear to you now? So the next we will see one thermochemical equation of heat of solution of KCl and CuSO4 in water. So when KCl is dissolved in water to form an aqueous solution of KCl, so the delta H is equal to plus 18 66.6 kilojoule. Whereas when copper sulfate is dissolved in water to form an aqueous copper sulfate, the heat change is minus 66.5 kilojoule. That means the heat of solution of KCl is equal to 18.6 kilojoule, whereas the heat of solution of copper sulfate is equal to minus 66.5 kilojoule. So here you must think that why the sign is plus and minus. So there is the difference that these are the anhydrous salt, where copper sulfate is hydrated salt. So when the hydrated salt forms its aqueous solution, it releases the heat. Whereas when an anhydrous salt dissolves in a water, the heat is absorbed. Okay. So here salt when present in a hydrated form absorbs heat while dissolution, and when there are anhydrous form the release heat. That means when copper sulfate in hydrated form, that is 5H2O, when dissolved in a water, the heat will be positive. That means when it is present in a hydrated salt, the heat is absorbed, and when it is present in anhydrous form, the heat is evolved. So you must remember that when the salt are present in hydrated form, heat is absorbed, and when they are present in anhydrous form, the heat is released. Is it okay? There are two types of salt. One which do not form hydrates like NaOH, KCl, KNO3 and etc. And there are some hydrated salts like copper sulfate and calcium chloride. So the next is heat of hydration. That is the amount of heat change that occurs when 1 mole of anhydrous salt combines with the required number of moles of water so as to change into the hydrated salt is called heat of hydration. That means when anhydrous salt changes to the hydrated salt, the amount of heat absorbed or released is called a heat of hydration. So here we will take the example of copper sulfate. When copper sulfate reacts with 5 moles of water to form a hydrated form of copper sulfate, the heat released is equal to 78.2 kilojoule, and it is known as heat of hydration. The next term is heat of fusion. The heat of fusion is the heat change that takes place when 1 mole of solid substance changes to its liquid state at its melting point. For example, when ice changes to its liquid state at their melting point, that is 273 Kelvin, heat of fusion is 6.0 kilojoule per mole. That means when ice get converted into water, the heat change accompanied with this reaction is equal to 6.0 kilojoule per mole, and it is known as heat of fusion. The next is heat of vaporization. It is the heat change that takes place when 1 mole of a liquid changes to its gaseous state at its boiling point. Now, when liquid transferred to its gaseous state, that means when water changes to it in the steam form, whatever the change in heat is equal to 40.7 kilojoule, and it is known as heat of vaporization. The next is heat of sublimation. Heat of sublimation of a substance is the heat change that takes place when 1 mole of a solid changes directly into vapor phase at a given temperature below its melting point. So first of all, you must know what is the sublimation process. In sublimation, the solid substance directly gets changes into its gaseous form, and whatever the heat change that occurs during this reaction is known as heat of sublimation. Now when iodine in its solid state changes directly into its gaseous state, the heat change is equal to 62.39 kilojoule. Is it okay to you? The next is bond enthalpy or bond energy. The bond energy of a particular bond is defined as the average amount of energy released when 1 mole of bond are formed from isolated gaseous atom, or the amount of energy required when 1 mole of bond are broken so as to get the separated gaseous atom. That means the amount of heat change when 1 mole of bond is formed, or the amount of heat change when 1 mole of bond are broken, is called as bond enthalpy or bond energy. So there are some subpoints. The bond energy for the diatomic molecule. The diatomic molecules like H2 and HCl. That means in that molecule only one bond is present. And the heat change when that one bond is broken or that one bond is formed is known as a bond energy. Okay, and that is also equal to dissociation energy of that molecule. Is it okay? The bond energy for the diatomic molecule like H2, HCl, etc. is equal to the dissociation energy of the molecule. Now for the polyatomic molecules such as CH4. So in methane molecule, there are 4 CH bond. That means whatever the bonds that are present in that molecule, all are equal. The bond energy for the 4 CH bond are different. Therefore, the average value is taken. That means when CH4 and one hydrogen is removed from it to form CH3, that energy is different. When two hydrogens are removed, that energy is different. So whatever the energy that is released during this bond formation, that value is taken and the average value is taken as the bond energy. Heat of the reaction can be calculated from the bond energy data. Till the today's lecture, we know that heat of the reaction can be calculated by using the values of enthalpies of formation of each molecules. Okay, but from this lecture we know that heat of reaction can also be calculated by knowing the value of bond enthalpies of respective bonds. And how it is? It is the summation of bond energy of reactants minus summation of bond energy of product. Is it okay? So this is the table in which there are the values of bond enthalpies or bond energy for the some common bonds. So this is also given in your textbook. So you can refer it or you will have this table with you. Okay. So here we will take one numerical. Calculate the enthalpy change of the reaction. The reaction is H2 reacts with Br2 to give twice HBr. Given that the bond energies of HH, Br bond and HBr bond are 435, 192 and 364 kilojoule per mole respectively. So this is the question. So first of all, we will write the given things. What are the given things? Bond energy for HH bond is equal to 435 kilojoules per mole. Bond energy for BR-BR bond is equal to 192 kilojoules per mole, and bond energy for HBr bond is equal to 364 kilojoules per mole. So now we know the formula that delta H for the reaction is given by summation of bond energies of the reactant minus the bond energy of the products. Is it okay? Next. Now putting the values. So first we will see for the reactant terms. So the bond in the reactant, there is one bond of HH, that is bond energy of HH bond plus, why plus? There is a summation bond energy of BR-BR. The bracket complete minus. Now product side, there are two HBr bonds. So 2 into bond energy of HBr bond. So now putting the value. So bond energy of HH is 435. Bond energy of BR-BR bond is 192 minus 2 into bond energy of HBr bond is 364. So now calculating this, addition gives 627 minus 2 into 364 is equal to 728. So the answer is minus 101 kilojoule per mole. So the enthalpy of reaction for is equal to minus 101 kilojoule per mole. Is it clear to you now? Okay. So here we will stop our lecture. Thank you. Thank you so much.